Now, you can't find living dinosaurs nowadays, which is a good thing, mostly, but you can still meet some creatures that might have gone to lunch with them. The frilled shark, for example, is a living fossil that comes from a family of sharks that have been around for about 80 million years. One of the coolest things about it is its long, eel-like body that can grow as long as 6 feet. It has 6 pairs of gills on its throat, which help the frilled shark breathe in the deep, cold ocean where there isn't much oxygen. The shark can move very quickly, like a snake, to catch its prey when it least expects it. Little frilled sharks take an exceptionally long time to grow, up to 3.5 years, which is one of the longest times for any animal with a backbone. The Chinese giant salamander is another living fossil that can tell you what was going on Earth around 170 million years ago. Now, when I say tell, I really mean it, as it can make sounds like hisses, whistles, and barks, and even a noise that sounds like a crying kid. The biggest Chinese salamander found so far weighed 130 pounds, as heavy as 2 Dalmatians, and was almost 6 feet long. Giant salamanders like to be alone. Hey, I want to be alone. And will chase away other salamanders from their space, except when it's time to start a family. During the day, they hide and sleep under rocks. They can make a special substance from their skin that keeps predators away. Now, gharials are reptiles that have been around for about 38 million years. They live in India and Nepal in slow-moving, muddy rivers. Sadly, there are very few gharials left in the wild, less than 100. These creatures can't control their body temperature, so they need to sunbathe to get warm or cool down in the water if they get too hot. Their eyes are close together and face forward, which helps them see in 3 dimensions and judge distances more accurately. Gharials also have a transparent third eyelid that protects their eyes when they're underwater. They have over 100 sharp teeth, but they can't chew their food. Instead, they use their strong jaws to grab prey and then, swallow it whole. The alligator gar is a fish that has a family history of more than 100 million years. It still has some cool features from ancient times, like being able to breathe both air and water. It also has a special spiral-shaped intestine, like a shark. The alligator gar is one of the biggest and heaviest fish in North America. Just like an alligator, it has a long body and snout, plus a row of sharp teeth. But instead of legs, the gar has fins to help it swim underwater. The tuatara isn't a lizard as you might think, and isn't a dinosaur either. This New Zealand resident is one of the most unique animals in the world. Scientists love studying tuataras because they can help us understand how today's lizards and snakes evolved. One of the coolest things about the tuatara is its third eye, called a parietal eye, on its head. It has its own lens, retina, and a nerve that connects it to the brain. Scientists think it might help the tuatara know when it's light or dark outside and absorb sunlight to make vitamin D or help them keep their body temperature exactly right. Tuataras can live an extraordinarily long time, up to 100 years. Cassowaries are the youngsters on our list, as they've been around for only 60 million years. They have some things in common with dinosaurs, like their 3-toed feet and how they breathe. Cassowaries love to eat fruit, lots and lots of fruit. This love of fruit helps the rainforest, because when cassowaries eat the fruit, their bodies don't harm the seeds inside. As they move around the forest, they spread these seeds, you can guess how, with their own natural fertilizer, helping new plants grow. Cassowaries are big birds, about 6 feet tall and weigh over 100 pounds. They have a special claw on each foot that is 5 inches long, and they can use it to kick real fast. If they feel threatened, they can charge, kick, and even jump on someone. They can also leap up to 5 feet in the air. So, the best thing to do is stay far, far away from where they live. The order Notostraca is a group of crustaceans that you may know as tadpole shrimp or shield shrimps. These animals have been around for about 360 million years. They have a wide, flat shell that covers their head, and they have a pair of eyes on top. These creatures can be found all over the world in different kinds of water, like freshwater, brackish water, and even salty pools. They can also look different depending on where they live. Notostraccans aren't picky eaters and can snack on pretty much anything, from plants to small animals and other shrimps. Some of them are considered pests in places like California rice paddies because they stir up the mud, which blocks sunlight from reaching the young rice plants. Sturgeons are some of the largest fish species on the planet. They live only in the cool waters of the northern hemisphere and never travel below the equator. Even though they are huge, sturgeons don't have teeth. They eat by sucking food off the bottom of rivers, gulfs, lakes, and oceans. Scientists believe that sturgeons came from a group of fish that first appeared around 419 million years ago, long before dinosaurs even existed. Their ancestors survived a big extinction event that wiped out 90% of all species and went on to become the largest fish in many rivers in North America and Eurasia. Sturgeons can live up to 100 years old or even older. Female sturgeons can lay up to 3 million eggs at a time, but not all of the eggs eventually turn into real fish. Our next hero, the Pacific lamprey, has successfully lived through at least 4 mass extinctions. Its ancient ancestors evolved over 450 million years ago. These creatures have cartilage instead of bones and a third eye, which is a special light-sensing organ on top of their heads. Instead of a regular jaw, they have a mouth surrounded by teeth. They latch onto prey and sup up body fluids like real underwater vampires. And although he wasn't living underwater, the story goes that King Henry I of England might have lost his life because of a lamprey. The English monarch loved this fish so much that he defied doctors' orders to stop eating its flesh. He got sick every time he'd have it, but the lack of bones and the unusual taste made the royal fall in love with it. As a result, he got some scary symptoms from eating lamprey and eventually passed away. Can you say clueless? The elephant fish, also called the Australian ghost shark, has been on Earth for around 400 million years. Even though they're related to sharks, they aren't actually sharks. Instead of bones, their bodies are made entirely of cartilage. These fish have a special shiny tissue in their eyes that can make their eyes look like they change color from yellow to green. Elephant fish can be pretty tough and will fight back if they feel threatened. They like to be alone and usually don't hang out with other fish. Horseshoe crabs also deserve the title of survival champs, as they've been around even before dinosaurs, since 450 million years ago. 4 species are still roaming the ocean from Maine all the way to Mexico. Horseshoe crabs are more like spiders than ticks than they are like real crabs. They have 9 eyes, plus extra light sensors near their tails, so they can see really well. They breathe underwater using flap-like gills near their belly, and sometimes they use these gills to swim upside down. Every spring, when the tide is high, these creatures come up to the beach at night to mate and lay their eggs, and you can see hundreds of thousands of them.
Billions of years ago, our whole solar system was nothing but a big cloud of dust and gas floating in space. Then, something happened to disturb that cloud, but scientists still aren't sure what exactly it was. It could have been a distant star that turned into a supernova with a bang that caused the dust cloud to start spinning. As it spun faster, the dust and gas got pulled into the center and created a thick, spinning disk called a solar nebula. The gravity at the center became so strong that hydrogen atoms started crashing into each other, producing helium and a lot of energy. As a result of all these space shenanigans, we got our sun about 4.6 billion years ago. This process used up more than 99% of the dust and gas in the big cloud. The leftover stuff started to come together to make different shapes. The cloud kept spinning, and bits of matter bumped into each other and stuck together. Some of these clumps got big enough to have their own gravity, which pulled even more matter to them. This is how the planets, including our Earth, were made. You wouldn't recognize our planet though, as it was nothing like we know and love it today. It was hot, and I'm not talking about perfect beach weather hot. It was scorching hot, as it was mostly made of magma, which is basically melted rock. Just imagine how hot it should be to make the stones melt. After a few 100 million years, Earth started to cool down. As the planet changed and its outer crust started to form, there were lots of volcanic eruptions. These volcanoes released water vapor, ammonia, and carbon dioxide into the air around the planet. Slowly, oceans started to form from the water vapor. The planet was every introvert's dream back then, with not a single living being around until the day when the first simple lifeforms began to appear and live in the new oceans. Those tiny organisms were single-celled microbes that gave birth to all future lives, including yours. They left signs in rocks that are about 3.7 billion years old. The signs were a type of carbon molecule made by living things. Then, at least 2.4 billion years ago, cyanobacteria evolved. These were the first organisms to make food using water and the sun's energy, and they released oxygen. This caused a big increase in oxygen, which made it hard for other microbes that couldn't handle oxygen to survive. Then, tiny microbes started living inside other tiny microbes. This way, they were forming organelles, small structures inside a cell with a specific function. One important organelle is called mitochondria, and it helps turn food into energy. For the first time, DNA got packed inside a part of the cell called the nucleus. These new complex cells, called eukaryotic cells, had different parts that each did a special job to help the whole cell work better. Soon enough, the earliest animals would rule the world. But don't get your hopes up. They weren't fluffy kittens. All the changes on Earth were happening against the background of the supercontinent Rodinia, which formed around 1.2 billion years ago. It pulled together almost all of Earth's land masses into one gigantic piece of land. It was surrounded by a massive ocean, so the whole planet looked like a giant land and sea puzzle. Unlike the green, lively continents we have now, Rodinia was barren and rocky, with no plants or animals on land. So, early life forms like algae thrived in the ocean. The breakup of Rodinia caused changes in Earth's climate and ocean currents. New coastlines and environments eventually helped diversify life on Earth. Cells began living together and finally evolved into the first animals around 800 million years ago. Sponges, and I don't mean the loofah you use to shower, were some of the earliest animals. By around 580 million years ago, they had neighbors, including fronds, ribbons, and quilts. But then, another 40 million years later, which is like a minute in evolutionary time, the conditions changed. Oxygen levels rose, and the first animals were replaced by new life forms. It was the beginning of the Cambrian period, the time of the giant shrimps and other creatures you'd rather never meet. Those invertebrates that ruled the planet looked so weird and not Earth-like that it took scientists years to realize these scary creatures were actually the ancestors of modern mollusks and crustaceans. Meet Hallucigenia, a creature with 7 or 8 pairs of spindly legs, the same number of paired spikes coming from its back, and a head you won't tell from its tail. Another cool creature from that period was the abnormal shrimp. Unlike most animals back then that were tiny, it was over 3 feet from head to tail. There was also the Weewaxia, that looked sort of like a stegosaurus, but without a head, a tail, or any legs. It looks like these creatures were born without defensive spikes and grew them as they got older. If they ran a beauty contest in the Cambrian period, Aishia would likely win, It had many common features with today's tardigrades. Although it was just 1 or 2 inches long, it was the nightmare of prehistoric sponges, and it clung to them with its multiple claws. We still have some live souvenirs from the Ordovician period living among us. Take lampreys, for example. The marine life kept flourishing. There were squid-like nautiloids with tentacles and a special shell with gas-filled chambers that made them float in the water. They swam well by squirting water out of their bodies and used their tentacles to catch prey. Another group of sea hunters was the conodonts with their tiny fossil teeth. The few complete fossils we have found show that they looked like eels with big eyes to spot their food. Fish back then were small, with mouths that pointed downward, which helped them suck up food from the ocean floor. Lampreys and hagfish are their living relatives today. The hard-bodied arthropods, like early relatives of crabs and spiders, started exploring life on land. They moved into freshwater and shallow lagoons, and one type of these creatures was the horseshoe crab. Even though they're called crabs, they're actually more like spiders and scorpions. Around this time, the first simple plants also began to grow on land. But a surprise ice age interrupted their plans. Most of the world's land at that time came together to make a huge supercontinent called Gondwana. It included what is now Africa, South America, Antarctica, and Australia. Another supercontinent, called Laurentia, included what would become North America. Gondwana drifted south until it settled at the North Pole. Huge glaciers started forming over what is now Africa. This led to a 20 million year ice age and a huge extinction. At least half of all marine species were wiped out around 443 million years ago. The landscape wasn't looking too cozy, but have no worries, the first plants were about to hit the land. As temperatures rose and sea levels climbed again, the oceans began to recover during the Silurian period. Huge reef systems grew in the warm, clear tropical seas. You can still see remnants of these ancient reefs today. They are limestone rocks. The oceans were full of tiny creatures called plankton. At the top of the food chain were these terrifying sea scorpions. Some of these sea scorpions grew to over 6 feet long, and they were the largest arthropods ever. They looked like giant scorpions with huge, compound eyes to spot their prey, the primitive fish. They caught it with their strong, claw-like pincers. Speaking of fish, they were starting to change and found new ways to eat, not just by sucking up food from the ocean floor. A group of spiny sharks developed jaws which made their mouths more dangerous. Even though these jawed fish weren't very big during this time, they were becoming better hunters and would later become top predators. On land, the first tiny, creepy crawlies began to show up. They were primitive centipedes and early ancestors of spiders. The first plants on land didn't have leaves, but they could stand up straight, thanks to their stiff stems. They also had special tubes inside them to move water and nutrients around, just like how our veins move blood. Mosses and other small plants soon followed and helped create a better environment for animals to start living on land too. The climate was nice and warm. The supercontinent Gondwana was still near the South Pole, but the big ice sheets from before melted away. Plants continued to grow and change during the Devonian period, but you'd probably be more impressed by a millipede as long as a car. If you visited the Earth back then, you'd wander in the first big forests made up of lycophytes, horsetails, and ferns. By the end of this period, the first successful trees appeared. They could grow really tall, up to 98 feet, about half as tall as the Leaning Tower of Pisa, and had thick trunks about 3 feet wide. They didn't have real leaves but had fern-like parts growing right on their branches and used spores to reproduce. The insects of that time were pretty wild. One of them was a huge dragonfly with wings as wide as a big pizza. This giant dragonfly lived in open places where it had room to fly, and its big eyes helped it spot its food, smaller bugs. It used its spiky legs to grab the insects it wanted to eat. Another monster from that time had wings about 22 inches wide and a mouth that looked like a beak. On the ground, the biggest bug ever known on Earth was wandering wild and free. It was a millipede as long as a car that likely ate fruits and seeds. The insect grew into such giants thanks to the extra oxygen in the air, up to 35% instead of the usual 21%. They could easily breathe even when they were huge, and there were no big birds to eat them, so they could grow really big and explore land and sky with nothing to worry about. But not for long. Fish started changing into the first animals that could live on land. These early fish had special fins that worked like arms and legs, and they could explore new swampy areas where there were lots of plants and no big predators. One of the oldest animals that show this change mostly lived in shallow water, where it walked on the bottom. It had a head that looked like a crocodile's, and it could move its neck and breathe air through its nostrils. It grew up to 10 feet long. Its back fins were bigger and stronger than the front ones, which helped it move on land. At the end of the Devonian period, Earth went through 2 long extinction periods when up to 70% of sea creatures disappeared. But the plants and animals living on land mostly survived these tough, cold times. It also had a cool, distant cousin, coelacanth. This fish was almost 5 feet long and had 4 fins that looked like limbs, but it never moved to land. It adapted to life in deep water, hiding in caves during the day and hunting at night. This deep-sea lifestyle probably helped coelacanth survive 4 of Earth's major mass extinctions. For a long time, people thought it was extinct until one was found off the coast of South Africa in 1938. So yep, it still lives in the deep parts of the Indian Ocean. During the late Paleozoic era, animals including a crazy mix of a polar bear and a saber-toothed cat got all independent and didn't have to live near the water anymore. They started laying eggs on land. Fish were becoming more different from each other, and trilobites were starting to disappear. New plants called conifers were growing, and 2 new types of animals also appeared. There were marine reptiles like early lizards and snakes and archosaurs, which later turned into crocodiles, dinosaurs, and birds. This period is sometimes called the Age of the Cockroaches, because an early kind of cockroach was lurking all over the world. But there was something way cooler than a cockroach, like a mix of a polar bear and a saber-toothed cat. It was an early relative of today's mammals with long legs that helped it run fast. It had sharp, saber-like teeth that could slice through the necks of huge plant-eating animals, but it used its teeth to rip big chunks of meat rather than chew. Scientists aren't sure if it had scales like its older relatives or fur like its mammal cousins, but they found hints of ancient poop that smaller relatives had hair, so this guy probably did too. There was also a big reptile that lived in the cold deserts of Eurasia. Imagine a creature as big and heavy as a black rhino, weighing about 2,400 pounds and stretching around 10 feet from head to tail. It was covered in thick, bumpy plates all over its body, which helped protect it from predators. Because it was so heavy and slow, it couldn't run fast, so these tough plates were its best defense. To stay so big and strong, Scutosaurus had to eat a lot of food all the time. It was one of the first big plant-eating animals to live on Earth. These animals were like early versions of big dinosaurs that came later. Even though Scutosaurus looked a lot like those dinosaurs, it was not closely related to them, kind of like how we're not closely related to whales and dolphins. The closest living relative to Scutosaurus is the tortoise, another slow-moving armored reptile. When you look at this guy, Dimetrodon, the first thing you notice is the big sail on its back that could remind you of some dinosaurs, but it was actually more closely related to us. It was a proto-mammal and had some unique features, especially in its skull. It had a small hole behind its eyes where jaw muscles attached, which is something dinosaurs didn't have. Dimetrodon also had different types of teeth for different uses, unlike dinosaurs that had rows of the same kind of teeth. The sail on its back was probably used to show off and attract mates, or scare away rivals. The last period of the Paleozoic, called the Permian, ended with the largest mass extinction on Earth ever. It wiped out more than 90% of all the species on the planet. The two big landmasses named Euramerica and Gondwana joined together to form one huge supercontinent called Pangaea. Around Pangaea was a giant ocean. Because Pangaea was so big, the middle of it was probably very dry, since rain clouds couldn't travel far enough to bring water to the interior. This made Pangaea's center a very dry place. The Permian extinction left room for new creatures to thrive. One of them was this guy, looking like a real-life Nessie from Scotland. It was a 20-foot-long reptile with a super long neck, even longer than its body and tail combined. And nope, it wasn't a dino yet, but a protosaurus that lived during the Middle Triassic period, which was just before the time of the first dinosaurs. Scientists used to think it was too heavy on top to walk on land because of its long neck, but newer studies show that most of its weight was centered around its body, so it could walk just fine. Between 240 million and 230 million years ago, a new successful group of animals started to rule the world. They managed to evolve from mostly dog and horse-sized creatures into the biggest monsters that ever existed on Earth. Scientists say they managed to do it thanks to some massive volcanic events. But it's a topic for another video. Life during and after the dinosaurs.
So, theoretically, humans can survive an asteroid that has the potential to destroy entire planets. It won't be a walk in the park, though. Let's go back in time to 66 million years ago, in the late Cretaceous period. The Earth, before humans, where dinosaurs are thriving. The plants and animals are rich and diverse. You'd see a T-Rex chasing a Triceratops, or the massive Alamosaurus, one of the biggest animals to ever roam the planet, towering over the landscape. In Texas, they remember the Alamosaurus. And watch out for the Ankylosaurus, a living tank swinging its tail like a wrecking ball at any threat. As you're about to enjoy a quiet evening under the stars, a bright new light appears in the sky of the northern hemisphere. Now, a new star in the sky doesn't really stand out at first, it's just twinkling like the rest. But give it a few hours and you'll notice it's getting brighter. Check again the next night and boom, it's the brightest thing in the sky, outshining planets and even the moon. Then finally, it horrifyingly outshines the sun. The star was the Chicxulub asteroid, which left a gigantic crater now called Chicxulub Crater in Mexico's Yucatan Peninsula. The asteroid enters the Earth's atmosphere at a blistering 12.5 miles per second. It blasts through 60 miles of the atmosphere in about 3 seconds. It falls so fast that even the air can't get out of its way. The air gets squashed and heats up to thousands of degrees in a blink. Before the asteroid even touches the ground, this super hot air has already vaporized much of the sea where it's about to strike, near the Yucatan Peninsula. Then, in a flash, the asteroid smashes into the Earth, screaming over Central America with a loud boom that echoes everywhere. It doesn't just smash the ground, it makes the soil and rock flow like liquid. The asteroid digs a hole so wide and deep that it nearly touches Earth's inner layers and throws up dirt more than 20 miles high. At that exact moment of impact, The asteroid also turns its massive speed and weight into heat in a split second. It puts so much energy into the Earth that it makes molecules move faster than the surface of the Sun. This massive energy created a giant ball of plasma, superhot charged gas that includes bits of vaporized rock. This all shot out at incredible speeds. The shockwave from the impact and the heat turned the Earth around the crash site into gas instantly. This set off earthquakes all around the world. And it's not just the rocks flying around that you need to worry about. As they plummet through the sky, they rub against the air, heating up so much that they set fires all around the world. The heat they give off could be compared to an oven cranked up to its highest setting. This fiery shower causes most of the world's trees to burn down. The entire world is now on fire. Soon it changes everything. In a blink, dinosaurs were wiped out, making way for mammals to rise. And not only dinosaurs, 75% of species and big creatures disappeared, leaving behind only some small birds and critters. So, how could you, a human, survive something like that? Now, some animals made it back then. To survive, we need to learn from their resilience. The only birds that survive even in the toughest conditions are the ones nesting safely on the ground. Among the few larger animals that manage to dodge extinction, all have ways to deal with the heat. Some, like certain small mammals, snakes, and lizards, can dig themselves into cooler underground burrows. Others, like crocodiles and turtles, just hide in the water. So, if you're exactly on the other side of the planet when the strike happens, and you act super fast, you might just make it. Right now, the impact is about 10,000 miles away, but don't underestimate its power. As soon as you hear the loud boom, head underground as quickly as you can. And be careful, because you'll feel the Earth shake about 30 minutes later. Hide in a deep cave, preferably with a narrow entrance. It would protect you from the falling debris, and the temperatures underground would be stable. Also, some caves have natural water sources, rivers or streams. You might also prepare for the not-so-great diet of insects, fungi, or poor small animals that also seek refuge in the cave system. But it's better than nothing. You also need to be extremely far away from any large bodies of water. Being near the ocean might seem like a safe bet during a massive asteroid impact because the sea can buffer extreme temperature changes. But the earthquakes trigger terrifying tsunamis, even in lakes or fjords. The asteroid's crash sets off not just one tsunami, but many, and they're as tall as skyscrapers. Within an hour, colossal waves between 600 and 1,000 feet high hit the Gulf Coast, slamming into places like Mexico and the southern United States, and flooding miles inland. These waves are so powerful, they even push rivers backward. These tsunamis continue around coastlines, reaching the east coast of the United States, and 6 hours later, they hit Europe, Africa, and the Mediterranean. By 15 hours after the impact, there isn't a coastline on Earth that hasn't felt the wrath of these waves. Well, let's say you survived the initial impact somewhere deep underground, but your troubles have only begun. The Chicxulub asteroid strikes a region loaded with sulfur. This sends 100 billion tons of sulfur and an enormous amount of water into the sky. The water vapor forms massive storm clouds. They start to rain acid. In colder places, huge snowstorms bury the land under feet of snow each day. The impact also vaporizes massive amounts of oil, throwing up 150 football stadiums worth of it into the air. This oil turns into a thick black soot in the stratosphere. It coats the Earth like black paint. And even when the acid rain calms down, this carbon stays up above the clouds and doesn't wash away. This sooty layer blocks out 90% of sunlight, plunging the Earth into a cold darkness that lasts for at least 3 years. The world cools down by about 50 degrees on average. Now, when you finally leave your deep cave, you must look for places where you won't freeze. The only spots spared from the frost are tropical islands like Madagascar, India, which was an island back then, and Indonesia. These places have surviving plants and animals, and they even continue to get fresh water, unlike most of the world. Everything else in the world looks like a huge nuclear wasteland. These tropical islands are safe spots during an asteroid apocalypse, but don't think of them as paradise. These places still only get about 10% of their usual sunlight and barely enough rain to avoid turning into deserts. In this chilly, gloomy setting, most food chains fall apart. If you want to survive, you'll need to bring lots of extra food with you, for the next 6 years at least. Now, some things are lucky enough to survive. Fossils tell us that freshwater ecosystems did well, so staying close to a river or estuary might be your best shot at finding food. You could come across turtles, crocodiles, and some fish. Animals like clams, snails, and small crustaceans that live in the sediment also manage to hang on. And while a bit warmer than everything else, these places are no walk in the park. You'd need to pack warm clothes to have any chance of survival. Now, if we add all this together, the best spot for surviving the Chicxulub asteroid would be Indonesia. It's a mountainous, tropical country that consists of several islands. There, you'll find bearable temperatures, a bit of rainwater, and a deep cave for shelter. This could protect you from the falling tektites, the intense heat, and even help you find something to eat in the rivers and lakes. But if you stumble upon any shrew-like creatures while scavenging for food, time traveler, please let them be. It's not clear how many survived the Chicxulub impact, and eating one could have unforeseen effects on the future of humanity. Like, don't eat your great-great-great-great-great-great-grandfather, right? Hey, it's possible that Jurassic World is not just a fantasy. Dinosaurs could really be walking, swimming, or flying around somewhere out there, but not on Earth. Some scientists think there may be planets far, far away from our solar system where slightly different versions of T-Rex and other dinosaurs live. They got the idea based on the fact that our planet used to have about 30% higher oxygen levels than today. That's why complex and intelligent life forms like dinosaurs could develop in the first place. They also want to explore basic building blocks that are the reason why we have life on Earth. These building blocks are something we know as amino acids. They make proteins, sugars, and genetic material, RNA and DNA. They're consistent and mainly exist in one shape or orientation. There are two ways they can be oriented, right and left. That means they mirror each other, just like our hands. It's something we call chirality. For life to exist, proteins must have one form, which means they can be oriented right or left. On our home planet, almost all living things, from the smallest bugs to whales and elephants, have amino acids with a left-handed orientation. We're not exactly sure why things are set that way, but there's a theory that's because of meteorites that crash-landed on Earth 4 billion years ago. They brought specific kinds of amino acids and some other organic materials to our planet, and somehow set the pattern we have today. Maybe we could use special telescopes we created to search planets, especially those where conditions are similar to how they used to be on Earth back in time when dinosaurs existed. In that case, it would be better to watch them from a safe distance, because considering what they might look like, researchers say it might be a safer choice. That's a cool idea, but it's still very tricky. The history of life on our planet, especially that of dinosaurs, involved many catastrophic events and mass extinctions. There's always more room for new theories about dinosaurs. One of them says oil comes from dinosaurs. Interesting, but not true. Oil formed from the remains of sea animals and plants from millions of years ago. This was way before dinosaurs appeared. Tiny organisms ended up at the bottom of the sea. As bacteria decomposed animals and plants, they removed most of the oxygen and some other elements from them. It left behind only a sludge, which was mostly made of hydrogen and carbon. As time passed, those remains became covered with many layers of silt and sand. When the depth of the sediment increased to 10,000 feet or even more, heat and pressure turned the remains into natural gas and crude oil. It's possible that dinosaurs lived or fell in the sea and later became petroleum in the same manner. But no one has ever found crude oil containing their skeletons. So this is just an unproven theory. Then there's the feathered dinosaur theory, which, unlike the previous one, seems to have more foothold in reality. Back in 2010, researchers found evidence that 100 million years ago, there had been a dino species with ginger feathers. Another group of scientists claimed there had been a different species from 150 million years ago. Those dinos had freckles and reddish-brown feathers on the tops of their heads. The color patterns probably had their purpose. Maybe it was a way to communicate with other representatives of their species or to attract mates. But years later, scientists studied the Microraptor, also called a feathered dinosaur. They realized it had probably been more like a bird than a dinosaur. The key point is how birds replace their feathers. Birds that fly have to replace their feathers in a specific order, otherwise they won't be able to fly very well. And the Microraptor's fossils showed that this creature had changed its feathers in a similar pattern. So they're not really sure which category this animal falls into. Dinosaurs that had feathers shed a lot of their skin piece by piece, like dandruff. "Hey Bob, looking a little flaky there. Need a new shampoo?" Yeah, they didn't shed their skins like lizards do, as if they take off an old suit. When we talk about dinosaurs, we usually don't picture them as social creatures, more like isolated ones similar to lizards. But some researchers discovered an 80-million-year-old collection of clutches in the Gobi Desert. It means there were colonies of dinosaurs that protected their nests and guarded their young, similar to birds. Crocodiles are known for doing that too. Pterosaurs were flying dinosaurs, and pelycosaurs were fin-backed ones. Some studies have shown that these two species used their exaggerated head crests and sails or fins to get to their potential partners. There are many theories about their crests and what they were needed for, though. Some experts believe that was how dinosaurs regulated their temperature. Others think they needed a crest to steer through the air. It's hard to say anything for sure since their fossils are rare and they don't have living descendants. But the most likely option is that the crest had the same purpose as a peacock's tail and was used for selecting mates. The bigger the crest, the more chances a pterosaur had to get a partner. You know theropods, those scary meat-eating predators that are shown in most dinosaur movies? Well, they might have enjoyed eating plants way more than tearing flesh. Not all of them, but it's possible that many of them weren't as fierce as we might think. Those big scary ones, like T-Rex, could be exceptions rather than the rule. The thing is, movies show these creatures to be way faster than they probably were in reality. They could probably run just a little bit more quickly than the average human runner. Scientists study the diet of coelurosaurs. Those seem to be the closest relative to birds. It was hard to figure it out because some of the dinos from this group had peg-like teeth, or in some cases, no teeth at all. To understand what they ate, researchers had to look for direct evidence and check if there was anything in their stomachs. And after they discovered certain things, including a beak with no teeth, they realized these fellas had followed a vegetarian diet most of the time. Even some famous ones, such as velociraptors, could be just innocent plant eaters and not terrifying beasts from Jurassic Park and our childhood nightmares. Over 10 years ago, scientists found fossils of a small dinosaur. It was a creature as big as a parrot with long legs. It came from a family with some of the most famous predators we know about, such as T-Rex and Velociraptor. Most dinosaurs that lived on land had 5 fingers, but later some of them ended up with fewer fingers. This new one they discovered was special because instead of having 3 fingers, which was more common for its family, it had just 1 finger with a sharp curved nail at the end of each front limb. This creature probably used this 1 finger to dig into insects' nests to feast. Even though we know all about the asteroid that wiped out dinosaurs, some have other theories. One paleontologist even had an idea that dinosaurs had possibly reached their end because they had been eating one another. This especially worked for ancestors of fierce, scary predators such as the Tyrannosaurus rex. It's possible they ate so many eggs of other dinosaurs that many species just went extinct. Once they started eating the eggs of very big dinos that we know as sauropods, it's possible they started getting bigger too. And no dinosaur mother could stop them from eating her eggs because she couldn't be around all the time. There were other big predatory animals that ate eggs, even early mammals. But in any case, later research showed dinosaurs couldn't have eaten enough eggs to have caused mass extinction. And that's all I have to say about that.
Around 66 million years ago, dinosaurs disappeared from the Earth, except for the ones that eventually turned into birds. Suddenly, the Earth went from the age of dinosaurs to the age of mammals. Scientists have special names for these time periods: the Cretaceous and Paleogene. And the event itself is called the KPG, or KT extinction. Picture this dramatic moment in Earth's history. It happened in the blink of an eye. A colossal asteroid as big as Mount Everest and traveling at lightning speed slammed into Earth. It crashed down in what we now call southern Mexico, at a place known as the Chicxulub crater. The impact was gigantic. Everything close to it was instantly vaporized, creating an enormous burst of energy, one of the most powerful in billions of years. Nothing could survive near the crash site. As the fiery aftermath cooled, the Earth's surface went haywire. The ground twisted and trembled, causing unbelievable earthquakes. The continent started to literally bounce. Then, the ocean floor got all stirred up, provoking the gigantic tsunami. Massive waves surged inland around the Gulf of Mexico. The debris that got blasted into the sky started falling back to Earth like a rainstorm. Even if you weren't close to the huge pieces falling in Mexico, you'd still get hit by smaller, super hot bits flying through the air. This heated up the atmosphere so much that forests all over the world burst into flames. The dinosaurs that lived far away from the impact area first felt a little rumble. Suddenly, the sky turned dark and gloomy, as if it was nighttime during the day. The temperatures dropped drastically, and this night during the day lasted for several weeks. And then, a blanket of ash started slowly covering the entire planet. Nasty things like carbon dioxide and bits of the seafloor started floating around in the air. This messed with the temperatures once again, making it swing wildly. The Earth was hot and cold at the same time. Nature was suffering. Forest fires, no sunlight, dangerous gases in the atmosphere. All this caused big problems for plant-eating dinosaurs. They started to vanish, and the meat-eaters were having a feast. But not for long. Soon enough, the whole food chain fell apart. This is when somewhere between 50 and 80% of dinosaurs said their final goodbyes. What's even sadder is that this number only counts the different types of dinosaurs. If we look at the number of individual dinosaur lives lost, it's even higher. Here's an interesting fact. If the asteroid had hit just 30 seconds earlier or later, landing in the Atlantic or Pacific rather than just off the coast of Mexico, we might have had some non-avian dinosaurs still around today. But the way it happened, the asteroid struck with a force equal to 10 billion Hiroshimas. But the only ones who made it were our mammalian ancestors. They were little shrew-like creatures who had super fast energy systems, adaptable diets, or clever hiding spots. These early mammals survived because they were tiny and didn't need much food. We're incredibly lucky that they survived this chaos. They probably didn't even understand what was happening. They just noticed the horrible smell, huge bodies everywhere, acid rain, and volcanoes erupting. So now that we know how terrible this event actually was, let's talk about a big question. Could we, modern humans, survive something like this? Well, it depends. Research from a different asteroid impact about 790,000 years ago suggests we could, but it wouldn't be easy. In that other event, a massive asteroid hit Earth once again. Just like with the Chicxulub asteroid, it sent debris into the atmosphere that covered a tenth of the planet's surface. Scientists found the pieces of that asteroid's impact, glassy rocks called tektites. they analyzed these rocks and discovered a rare mineral called rhyodite. It requires extremely high pressure and temperatures to form. After studying it, scientists assumed that the impact happened in Southeast Asia, probably near Thailand. Strangely, they still haven't found the exact crater. But the main thing is, the asteroid collision did happen, and our ancestors were around during this. It surely got their attention, even though they might not have fully grasped what was happening. The debris from this event would have caused significant climate changes. It's tough to understand how it affected our humans' evolution. All that we know is that we survived it. Currently, there are about 1,200 asteroids on a list of potential asteroid threats, but luckily we're not in immediate danger. These asteroids are smaller than 0.6 miles in diameter. The chance of a massive asteroid like the one that hit Chicxulub between 3 to 9 miles wide, striking Earth is incredibly low. Major events like this happen about once every 100 to 200 million years. On top of that, most asteroids are located between Mars and Jupiter and don't pose a threat to Earth. However, there are thousands of smaller asteroids that could potentially hit us. Most of these are small and burn up in the atmosphere, causing no harm. Some larger ones could damage buildings or cities, but wouldn't threaten all life on our blue planet. But what if a comet or a serious asteroid were to collide with Earth today? In that case, first of all, it could alter Earth's orbit. The initial energy released during an impact would cause a scorching blast wave of 570 degrees Fahrenheit. The fire would ignite vast areas of the Earth's surface. Then, it would cause a long-term impact on winter. The smoke from the megafires, along with dust and water vapor, would form a thick layer of clouds in the upper atmosphere. Just like with the dinosaur event, it would reduce sunlight and cause temperatures to drop for decades. Most plant life would die off within weeks. Large trees might survive for decades due to stored sugars and a slow metabolism. Beyond that, not much life would remain, except for microbes and smaller creatures. There are 3 possible strategies for humans to deal with all this mess. The best strategy is to prevent the impact in the first place. Scientists are already searching for asteroids that might cross Earth's path and discussing how to defend against them. One option is to use our biggest weapons to break up the asteroid into smaller pieces. These tiny pieces could miss Earth or burn up in our atmosphere. That would work for asteroids around 0.6 miles wide. However, this won't work for massive Chicxulub-sized asteroids. The amount of energy we'd need to destroy them exceeds our entire current arsenal. But if we notice the asteroid early enough, maybe a series of blasts could change its course and save the day. And, according to the researchers, asteroids larger than 25 miles in size would be nearly impossible to stop with our current technology. Luckily, the chances of something like this hitting Earth are very tiny. But okay, what if we can't prevent the impact? Here comes the second strategy. We'd have to go deep underground and create large bunkers. We know that many burrowing or deep-sea species survived the mass extinction 66 million years ago. So these underground habitants could protect us from the direct impact effects like blasts and fires, as well as an impact winter. We'd have to harness the Earth's natural heat and live inside protective domes. They could be built in stable continental cores or deep beneath the oceans. We'd have some essential supplies like food, medicine, fuel, and water. Maybe even have some gene banks to preserve species. And the last strategy would be to copy the movie Don't Look Up and to ignore the problem until it's too late. We know that it would take collaboration among governments and institutions from many countries to design, build, and launch a series of devices into space in order to prevent the impact. If humanity will be able to pull that cooperation off, that would be a miracle. In any case, NASA takes the threat of asteroids pretty seriously. It has a well-thought-out plan involving early detection, assessment, deflection strategies, collaboration, public communication, and backup plans to protect Earth from these cosmic dangers. So we can only hope that if something like that happens, logic would prevail.
Are you sure that it was an asteroid that caused the extinction of dinosaurs? There's this huge drama about why these horrifying creatures disappeared. It's a big deal in both science and movies. But what really happened to the dinos? How do scientists figure it out? And why does it even matter? Let's see. Let's take a trip back to England in 1842. There was a scientist named Sir Richard Owen. He was checking out some huge reptile fossils and noticed that 3 of them, Megalosaurus, Iguanodon, and Hylaeosaurus, had a lot in common. So he had this light bulb moment and decided to combine all these creatures into Dinosauria, which means terrible lizards in Greek. The scientists were studying dinosaurs and grouping them based on their looks. But then, Charles Darwin showed up and gave even a better idea. Turns out, species don't just appear out of thin air, they evolve. And now, everyone had to rethink how they were defining dinosaurs. They came up with a new idea called phylogenetic classification. Picture a big family tree with all creatures ever. Somewhere up there, we find Megalosaurus and Iguanodon. And we say all dino descendants come from their common ancestor. It's like tracing back your family tree, and if we go far enough, we find the ultimate dino ancestor. Sounds like a plan. But then, things got a bit complicated. When we talk about dinos, we've got the ones with feathers and beaks and the ones without. That's when we found out that birds are cousins to certain dinosaurs, maybe even evolved from them. After learning that, scientists had to look at the bird family tree and rethink the dino definition. In the end, they decided that birds are kinda dinosaurs, but not exactly. Confusing, huh? But in any case, now we have 2 groups. The first one is birds, and the other one is non-avian dinosaurs, which are extinct. That means now we have to reconsider our question. Instead of asking what caused the extinction of dinosaurs, it should be what caused the extinction of non-good dinos. The answer might seem simple. People often think of a gigantic space rock as the dino destroyer. It's probably the first thing that pops into your mind. Even Google and other search engines agree on this one, like best friends copying each other's homework. History teaches us that about 66 million years ago, dinosaurs totally vanished, except for the ones that became birds. Of course, the truth is more complicated. And not all dinos vanished in one go. Some went the natural way, and there were many extinctions here and there during their time on Earth. But the big event we're talking about looks like a movie scene change. Like suddenly changing the channel on a TV. One poof. And the Earth went from the time of dinosaurs to the time of mammals. Scientists call these time periods the Cretaceous and Paleogene. We even give this special event a nickname, the KPG, or KT extinction. Some even refer to it as the 65 million years ago event, even though the more correct number is 66 million years ago. We've got 2 main theories in the spotlight: asteroids crashing and volcanoes erupting like crazy. Let's talk about the asteroid idea. So, around 66 million years back, imagine a humongous asteroid smacking into Earth. This thing was about 6 miles wide, about as big as Mount Everest. It zoomed through the sky super fast, like a mountain going 100 times the speed of sound. And when it hit, it released a ton of energy. It crashed down in what's now southern Mexico, near a spot that's tied to the dinosaur extinction story, Chicxulub crater. Everything close to the impact was zapped into vapor in a snap. Picture the biggest energy burst in ages, like 1 billion years or more. Nothing near the crash site stood a chance. Next, there was the aftershock. As the fireball cooled down, the Earth's surface went bonkers. The ground twisted and shook, causing unimaginable earthquakes. The continents became huge, bouncy castles. And then, The stuff that got blasted up by the impact came raining back down like a rainstorm. Even if you weren't near the huge pieces falling in Mexico, you'd get hit by these smaller, super hot bits flying through the air. This made the air so toasty that forests burst into flames all around the world. Are you ready for more? Time for a massive tsunami. The ocean floor got all churned up, pushing waves inland around the Gulf of Mexico. But just imagine, even all that wasn't enough to destroy all the dinosaurs. For example, dinos in New Zealand were pretty fine, but we know that they all went extinct. So what happened to them? They felt a little rumble, and suddenly, the sky started getting all dark and gloomy, as if it was nighttime. And hold up, what's that? A blanket of ash is slowly creeping around the whole planet. Now, here's where the real drama happens. The big problem with the asteroid crash wasn't the instant boom you might think. It's all about the long-term effects. Imagine the stuff that got blasted up into the sky blocking the sunlight. Days turn into nights, and temperatures drop very sharply. A lot of plant-eating dinosaurs passed away, and hunters were having a great feast, but not for too long. Without sunshine, the food chain falls apart very quickly. Then, the ash falls back to Earth. Things go from bad to worse. Other nasty stuff starts floating around in the air like carbon dioxide. This carbon dioxide mixed with shattered seafloor bits makes the temperature go wild. The Earth was playing hot and cold all at once. That's when somewhere between 50 and 80% of dinosaurs said goodbye forever. What's even more sad is that this number only counts the species themselves. If we look at the number of individual animal lives lost, it's even higher. You might think that at least the poor mammals finally got their chance after the dinos left. But even mammals had a tough time. We are very lucky that a few brave mammals managed to survive this crazy chaos. The ones who made it were like the little champs with speedy energy systems, flexible diets, or secret hideouts. But this story is only one hypothesis. Next, we have the volcanism hypothesis. Volcanoes. These fiery mountains are used to spitting out molten rock and causing epic destruction. But surprisingly, this theory isn't about explosive eruptions. Nope. It's about something sneakier and slower. Around 1 million years before the dino doom, there's this big change happening under the Earth's surface. Way below where India's floating, a rock river starts forming, heating things up. And then, India gets hit hard. It turns into a sea of lava, like a fiery ocean. It's like a gazillion of dump trucks filled with lava slowly pouring out. These solidified leftovers are known as the Deccan Traps, like a super deep layer of hard lava covering a piece of land the size of France. And just like in our asteroid story, the real trouble comes from the air. For hundreds of thousands of years, sulfur dioxide spread like an unstoppable shadow. It was making the sky gloomy and the rain toxic. Food sources turned into poison, and oceans became acid baths. And then, carbon dioxide took the stage. It was like a temperature button, flipping the Earth's climate upside down. It was a roller coaster of chaos. The ecosystems were stressed, food chains snapped, and species waved goodbye one by one. Both theories seemed pretty realistic. All the experts were having a big debate about which theory was correct and why the dinos disappeared. So, what is the real answer? Unfortunately, we don't know. Some scientists support one theory, some support the other one, and we're left scratching our heads. But hey, don't be too hard on the media or the scientists. They're all doing their best to figure out the mystery of the dinosaurs' disappearance. And maybe one day, we'll finally learn the real answer. So, stay tuned.